So in this video, we're going to be talking about some applications of the mounts we made in the last video and also get you started with some basic mechanisms that you can use in your projects. So the first application, and arguably the most important, is called a captive nut coupler. The way this works is, say I want to use this buzz on a peg and I want to rotate it using a servo. That's an awkward connection to make, and glue or tape would not be a strong mechanical connection. So what you're going to want to do to get started with a captive nut coupler is you bring out a cylinder and you're going to make it so that it's about twice the diameter of whatever object you're trying to couple together. And in this case, this diagonal is around 8 millimeters of the peg. So I'm going to make a hole in the center here that's around 8.5 millimeters. And then we highlight both, click L, align them. So that's where the peg is going to fit. Now we need a way to actually secure the peg onto the coupler. The way you're going to do that is by building a cavity for your nut. So I'm using a number 2 machine screw and nut, and I measured that nut's width to be around 4.8 millimeters, and it's 2.5 millimeters deep. And then the height, I'm just going to eyeball it to around 6 millimeters. Next, what you're going to want to do is set the Z position to negative whatever your height is, and that's going to sink it into your coupler. And then we're just going to quickly align those two. Next, we want to make the cavity for our screw. So the screw is around 2 millimeters in diameter. So I'm going to make the cavity 2.5, so there's a decent clearance. We're going to want to rotate that 90 degrees. We're going to highlight both of these, click L, and then center it all the way, just like that. Perfect. Now we're going to group. And this right here is your basic coupler. The way you can use this is, say, let's duplicate this servo mount that we made last time. We'll align these two, group them together. Now, as you can see, there's a place where we can attach it onto the servo, screw it into the servo, and then if we place this nut into this cavity here, it should hold the nut firm enough so that it won't rotate. Then all you have to do is place whatever object you designed this for into its slot. And then when you bring in a screw, in a lot of cases you use a grub screw or a set screw, and when you tighten that down, it will engage with the nut and apply force onto the side of whatever object you're trying to secure. And that is a really strong mechanical connection that's also safe because you can remove it if you need to iterate on this. So it's not a permanent attachment. Next, I'm going to show you how to get started with some cool mechanical applications. So in most cases, the first thing you're going to want to do is actually mount your actuator onto something. The easiest way to do this is to go onto Thingiverse. And I've already looked up the servo that we've been working with, which is the SG92R. And you can see right here, somebody's already made a mount. So in a lot of cases, this is a lot easier. All you have to do is go to Files, Download. This is a lot easier than actually measuring and designing it yourself, and you don't really run the risk of it being the wrong size. It doesn't hurt to actually check if the dimensions are roughly correct. But yeah, it's a lot faster. So this is already recessed, and it should fit the servo perfectly. Something you can do in Tinkercad also is you can look up servo, and a lot of times they will actually have the servo that you're using, since there's only a few really common servos. And as you can see, the servo pretty much just sits right in there. Next, what we can do is we can go back to this STL Gears website, and I'm just going to make a fun little gear mechanism, a rack and pinion. So for the module, I'm going to pick something like, let's say 3 millimeters. The classic pressure angle, like I said, there is around 20, 25. I'm going to do 20. Number of teeth, we'll do something lower than 20. We'll do like 15. And then gear length, let's set that to 5. It's a little bit thicker gear. Let's download that. And now let's also do a rack. So for the rack, the only thing you need to remember when you're building gears is, in order for them to engage, the module and pressure angle need to line up. So in this case, we'll do the module, what was that? 3, 20 degree pressure angle, Rack height doesn't matter. We'll just do 5. Rack width also doesn't matter. We'll do 10. Perfect. And now we'll download our number of teeth. Let's just do 20. Doesn't matter. Download rack. Then let's go back here and we will import our rack and pinion. Perfect. Perfect. Now what we can do is just roughly align, and I have switched my view mode to orthographic. This just makes it so that you are looking at flat planes, which makes it a little bit easier to align these. And again, you can just eyeball these. It really doesn't matter that much when you're working with non-precision, you know, racks or gears like this. So that looks about right. And then we'll align the rack so that it looks like it's going to engage with the teeth, but so that it doesn't hit the servo. I'm going to see the height of this mount right here, and it's around 3. So I'm going to build a little supporting structure so the rack can ride on, and I'm going to make that 3 millimeters, so it's the same height as the servo mount. And then just really quickly, just sort of eyeball a basic structure. Just like that. Now all that's left to do is, let's separate all these. I'm going to put a hole in the center of the gear, and the reason why I'm doing that is so that I can attach the mount that we made earlier. So let's make the hole around 8 by 8. That should be enough to fit the mount. I'm also going to set the height here to 0, and then I'm going to do Control D to duplicate this mount right here. I'm also going to make the mount and the gear the same height, just for continuity. Group them, and there you go. That's it. This is all the parts you need to make a simple rack and pinion. And as you can see, I went ahead and 3D printed this, and it works as intended. The servo was a little bit underpowered, so I added a little bit of WD-40 to make sure that the rack can slide back and forth smoothly, which in general is good practice when you're having these mechanisms that slide or grind with each other. Adding a little bit of wet or dry lubricant to your mechanisms to keep them from either jamming or wearing out too early.